So the allowable moment is 292 for Gibbs. Okay, but do you really need to do my over I? No, if you can remember some things, if you're pretty tricky. Okay. So the first thing to remember is that in a linear elastic situation, the stresses are triangular. And the centroid of a triangle is base over 3. So this distance here is KD over 3. And so traditionally, the distance, the internal moment arm between the concrete resultant and the tension resultant, we call JD. Okay. So in general terms, this is what we did just now. We did, remember, that was 18, that was 27.5. If you do everything in variables, okay, and then you do some tricky things like, what did I do here? Oh, divide by BD squared. So divide by BD squared. And you get A transpose over BD. Okay. Oops, that's a concrete, steel, I mean, because it's A transpose is N times AS. So the N's there. So A steel. So A steel over BD is rho. Okay, we'll talk about that more later. So here you go. This comes out nice. You get this. Use a quadratic formula, and you get this nice equation for K. So that's an easy way to get the neutral axis location. This is kind of a handy equation to have on a crib sheet or something. Okay. Okay, so K and J. So JD is D minus KD over 3, remember? Because it was a triangle, and that was KD over 3. And this is JD. And this distance here is D. Okay, so JD is D minus KD over 3. So J, okay, these D's cancel out, is 1 minus K over 3. Okay, so you get K from the formula. And then J equals 1 minus K over 3. And this is what you do. The moment, so remember the picture, you have C, T, internal moment arm of JD. A moment is couple, is just the force times the moment arm. So C times JD or T times JD, because obviously C equals T by summing forces. And so C is the area of the concrete force. Okay, it's a triangle, so 1/2. That's KD. That's FC. And then the width of the beam is B. And T is just the steel stress times AS. So let's redo the example using our little shortcut. Okay, so these are allowable stresses. We did that earlier. Okay, so here's rho. Remember, AS over BD. Rho times N is in this quadratic equation. Okay, you got that. And then you just plug that in there. You get 0.35. J is 0.8845. It's good to know that K is about a third and J is about 0.9, roughly. Okay. So if the concrete controls, okay, here's C, the area of this triangle, times the width. Okay, 1/2 F, the steel stress. So this is FC, FC, and this is, sorry, KD. Okay, so this is KD. Oh, where is it? There it is. KD. B. Okay, and you get that much is the concrete force if the concrete controls, JD right there, and the moment is 4224 kip inch, what we got before with some round off. If the steel controls, the tension force is FYAS over N. Okay. No, not over N, just FYAS. So there we go. JD is there again, same number. And T times JD is 3502 kip inch. Again, we'd round off the same answer. Okay, so that is how to do working stress design. But the key thing I want you to remember of all this, not all, is this. You can have an equation for K. And then once you have K, I do want you to be able to remember this, how to get I. Okay, so kind of key things to remember out of all this is K. And then KD, B, N, AS, and then get the moment of inertia. Okay, so I will see you all February 3rd. Looking forward to meeting you all.